Hello, dear students. Welcome back to my YouTube channel. As you all know that uh, we completed part first of 12th physics. So that means we completed electrostatics, uh, capacitor, current, electricity, magnetic field and magnetism, EMI, AC, EM waves. Now we are left with modern physics, semiconductor and optics. Hello, beta. So most probably within 8 days or within this week and some days of next week, we will be completing modern physics. Then next week we will be completing semiconductor, and then we will be having optics only. Okay. Then after completing my whole 12th the syllabus of physics, we will be starting 11th. In parallel to my 11th, we will be starting top numericals, top 100 or top 500 numericals from each chapter. Then NCRT solved and unsolved numericals. All these things we will be completing in next parts. Okay. So I hope that I am audible and visible to you. I hope. So let us now start. Okay. I hope that my face is visible to you, but I don't know why my 1 second. Don't know why there is some issue with my pen tab. 1 second. There is sometimes it lags, right? So I want you to give me some time. Give me some time. Hello. So I guess I'm audible and visible to you. Sometimes this glitch happens, no, due to the flood. No, the network gets affected. So it happens, right? So don't worry about it. So I got a comment from Srinidhi. Can I start from here, sir? I have backlog of some previous chapters, right? You can start from this particular one, right? The only reason is here that if you can go to the previous chapters like the EM waves, so EM waves contain some parts from previous chapters. In the same way, AC contains parts from previous chapter. Magnetism contains some parts from previous chapters. But here, if you are talking about the modern physics, it is a separate one, a different entity. You don't need the previous experiences. You don't need the previous knowledge. You don't need the previous any equation. It is entirely different. You can start from. If you don't know anything about physics, now here you will start. There is nothing to worry about. Okay, so today we will be starting the very lecture first of modern physics. So let us continue and let us start the very first chapter and very important one also of this one. I guess this my screen is visible to you. If you have any doubts or any queries about anything, you can just let me know right now. Then I will start my class. Then it is next to very difficult to give the answers to your numericals or to your things, right? Okay, now. So as you can see that the first thing that we will be discussing here it's modern physics, lecture number first. So the very main thing or the very first thing that you need to understand that what is modern physics or what is the percentage of importance of modern physics. So I will write here modern physics. Modern physics. Okay. In modern physics, if you can open your NCERT, if you can open your NCERT, you will find chapter number, you will find chapter number 11, chapter number 12, and chapter number 13. Then these are chapters of your modern physics 11, 12, and 13. And if we talk about NEET, if we talk about NEET, you will get 5 to 6 questions. 5 to 6 questions. That means 5 4 is 20, 24 numbers. So you will get 20 or 24 numericals only in what? Only in your NEET. So I guess it is a very important one. Okay, a very good one, a very starting one. So, but here, if we talk about here, so what we are going to study, we will be studying a first portion that we will study that is photoelectric effect. Photoelectric effect. Section A that we will study that is photoelectric effect. Section B that we will study that is matter waves. Session B we will study matter waves. Session C that we will study that is atomic structure. Structure. Session D that we will be studying nuclear physics. Nuclear physics. Session E that is X-rays. So how many sessions we will study under the name of modern physics? We will study 5 sessions. Photoelectric effect, matter wave, atomic structure, nuclear physics, and X-rays. Okay, but if you are very interesting in your NCERT, then these two, session A and session B, is from chapter number 11. These are from chapter number 11. Atomic structure is from chapter number 12. Chapter number 12. And these two came from chapter number 13. Chapter number 13. You need to note down, right? You have to note down these things so that you will get a very better understanding of what you are studying about. Done? Is there any confusion up to this particular slide? This is very first slide of modern physics. The very first slide of modern physics. Hereafter we will study modern physics. Is everything clear? Good to go now? And I want you to just comment below, right? So that I can get an understanding that now you are actively watching all these things. You are actively getting all these things. Done now? Okay, now I will go to the next page. Okay, I hope that you are done with this particular page. Now let us go to the next page. Look now. Next page. So we will study here section A. We will study here section A. Section A. In section A, what we will study? We will study photoelectric effect, photoelectric effect and photon theory. And photon theory. In first thing, we will study photoelectric effect and photon theory. So to get an understanding of photoelectric effect or your photon theory, let us suppose we are having a material here. Let us suppose we are having a material. We are talking about microscopic level. We are talking about micro level. Micro means, look now, what we are having here, sir, we are having small materials. Look here. Okay. These rings represent atom. These rings represent atom. And we know that with all atom we are having some electron revolving. With all atom we are having some electron revolving. I am starting with the scratch of modern physics. We know it, no? If you are just studying about the atom, if we are studying about the atom, so what are the main things that we are having with atom? We are having nucleus. We are having nucleus and we are having electrons. We are having electrons. If we need to make it, look, so this is my nucleus and my electron revolving around the nucleus with two shells. Suppose these are loosely bounded. These are loosely bounded, known as valence electrons. Known as valence electrons. Okay, if you know about their electronic configuration, 1s2, 2s2, 2p6, 3s2, 3d10, right thing. Okay, now when we are giving energy, suppose we are giving energy. Now we are giving some energy. We are providing some energy. So what will happen now? This energy gets absorbed by this electron, and this electron will go out from the atom. This electron will go out from the atom and it will go into the material or into the metal. Now this electron is known as free electron. This electron means free electron. So here we are having some free electrons. Here we are having some free electrons. Here we are having some free electrons. Now my aim is to get this electron out from metal surface. Now this electron goes out. Now you know that this metal, you know that this metal is neutral. This metal is neutral. Okay, when this electron goes out, so it gives positive charge to metal. When this electron goes out, it will give positive charge to the metal. Then this positive charge will get the back electron. Okay, so we are having a metal. If let us suppose electron goes out from the metal, this metal acquires positive charge. This positive charge attracts electron back to its original position. Done. But if we want to get this electron out and it shouldn't go back to its position, so we need to give extra energy. If this path to be followed, so we have to give some energy. We have to give some extra energy. some extra energy. Done. This extra energy we will provide in three different ways. Thermionic emission. Thermionic emission. जहां से बनाना बेटा, खुद का ध्यान रखो आप. Thermionic emission. First thing is thermionic emission. That simply indicates if we are giving energy, if we are providing energy to the metal in the form of heat. If let us suppose we are providing heat to the metal, due to this heat, energy gets absorbed by your electron and electron jumps out from your metal. This emission means to get out from something. This emission is known as thermionic emission, that is heat emission. Second type of emission known as field emission. Second type of emission known as field emission. Okay, field emission means if you are applying strong electric field. Strong electric field. As we know that this strong electric field will apply electric force from electrostatics. So electric field apply force towards your electron will leave its metal surface. Third emission known as photoelectric emission. Photoelectric emission, and this one is important. Only this one is important. Not this one, not this one, only this one is important. Photoelectric emission. If we are providing energy, if we are providing the extra energy in the form of light, that's I will call you, okay? But I will call you. So basically, if we are providing some energy, look, we have to provide some energy to the metal surface so that the electrons should get ejected from the metal surfaces, right? So we can provide the extra energy by different means. We can provide by thermionic emission. We can give heat. We can provide by secondary electric field, strong one. That means field emission, or we can provide the light. If light strikes energetic light, the more accurately is energetic light. If the more energetic light strikes your metal surface, the free electron will absorb this extra energy and this electron gets ejected from your metal surfaces. So this type of emission is known as photoelectric emission. This type of emission known as photoelectric emission. If I need to show you the photoelectric emission, so I will show you in this way. Look now. Look, here we are having surface. Look now. Okay, so in this surface, so look now, here light strikes here. So if here is free electron, this electron should leave its place. Now electron is here. This electron known as photoelectron. This one is known as photoelectron. So look, this electron absorbs some energy, then it leaves its position. So the energy that your electron absorbs, this particular energy known as work function. Done. This particular thing means work function. So what is work function? Work function simply means the minimum energy required by your electron. I will just repeat it. You need to write it. The minimum energy required by the electron to get out from the metal surface. This energy, this minimum energy is known as work function of that electron, of that metal also. Done? So look now, this metal surface requires some energy, no? When this metal surface will get some energy, so it will release its electron. So the minimum energy required to get the electron out from the metal surface, this energy is known as work function. And if you can open your NCERT, you will find cesium also. Now the minimum energy required is for cesium. If you can get the cesium out in your ultraviolet rays, right, it will get its photoelectrons out. Done? Now, as you can see here, electron here, now, look here, I'm just showing here, now, this electron is a particle. Here, electron is a particle. Electron is a particle. To get this particle out, I need one particle here. Look, if you need to replace particle, you need second particle. But what we are saying that light strikes your metal and electron gets out. So electron is a particle. To get electron out, I need particle. So here it is a proof of that light is made up of particle nature. Okay. So light is made of particle. Why? Look now, if electron needs to be get out from the metal surface, no, so particle will get replaced by particle only. Particle will get replaced by particle only, right? That means light is made up of small, tiny particles known as photons. Okay. So light is made up of small, tiny particles, and these small, tiny particles are known as photons. So you can write in this way: when light interacts with matter, then it provides its energy in the form of packets, and these packets of energies known as photons. Clear? Any issue? Any doubt? So here, which nature we are dealing with? We are dealing with particle nature. In optics, we will be discussing wave nature. So here at the end, what we will find? We will find that light is having a dual nature. Dual nature means, dual nature simply indicates if we are doing some particular experiment, light will show different nature. Light is having only two natures, wave and particle nature. When we are doing interference, diffraction, polarization, light behaves like a wave. But when we are doing photoelectric effect, quantum effect, right, light behaves as a particle. So sometimes it will behave as a particle, sometimes it will behave as a wave. So, but at the end, light possesses both nature, dual nature, duality. Clear? Is there any other issue related to this particular slide? If yes, then you can let me know. I am on the slide. If you find any issue or anything like that, I will show you now. Or if you want to write these things, you are most welcome. You need to write every part, everything on the slide. Okay. So these slides will work like a short notes. Okay. So if you can just read once the whole slide, you will get each and everything in your mind. Okay, particle, photons, okay, photoelectrons, work function, right? It is everything, no? Summation of everything. Done? If you are done with this particular slide, I will change the slide now. But you need to let me know, na? Okay, that means you are done with this slide. Going to the next slide. From the next slide. The very first property that you need to write, the first property is energy of photon. That means energy of photon. We are dealing with photons. The first property is energy of photons. Okay. So that for energy of photons, the equation that you need to write, that is E equals to h nu. What is E? What is E here? I will write here. E means energy. Energy. What is H? H is Planck's constant. Planck's constant. Do you know what is the value of Planck's constant? It is 6.63 multiplied by 10 to power minus 34 joule second. What is nu? Nu means frequency. Nu means frequency. One more equation that you need to remember, that means C equals to nu lambda. C means speed of light. C here means speed of light. And lambda means wavelength. Wavelength. Then, okay, next particle is in vacuum. If we are talking about vacuum, all photons, in vacuum, all photons, they travel with the speed of light, 310 to the power 8 meters per second. So if we are talking about vacuum, all photons travel with the speed of light. Speed of light. Done? Look now. Let us play with some more derivative problem. That means E equals to h nu. E means h nu. Done. So h nu here means joules. So we are talking about joules. If we want to study about, now sir, how to find about electron volt? If we want to study about electron volt, look, this one is in joules. I want to get this thing done in electron volts. So what I need to do, I have to just multiply, that means h nu. So I will do h nu and I will divide it with 1.6 10 to power minus 19. So my answer came into the electron volts. And I know one thing, that what is h? H means 6.63 10 to power minus 34 whole divided by 1.6 10 to power minus 19 frequency nu in electron volts. So this is a particular thing that it is given, and it is 4.1 10 to power minus 15 into frequency, but this thing is given into the electron volt thing. You have to write each and everything. Okay, E means h nu. H nu is in joules. If I need to convert joules into the electron volt, look, joules to electron volt, I will show here. If you need to go joules to electron volt, you need to divide with 1.6 10 to power minus 19. But if you are already in electron volts, you want to go to the joules, you need to multiply with 1.6 10 to power minus 19. Then if you want to go from joules to electron volt, you need to divide. If you want to go from electron volt to joules, you need to what? Multiple. Look now. Okay. One more thing. What is that now? Do you know that? One thing. 1 second, beta. E equals to h. Nu means C by lambda. What is h? 6.63 10 to power minus 19 multiplied by C. C is 3 into 10 to the power 8. It is in joules whole divided with lambda. Done. Now, if I need to change it in electron volts, what I need to do? 6.63 10 to the power minus 19 3 into 10 to the power 8 whole divided by 1.6 10 to the power minus 19 into lambda. This will come into the electron volt, and this is equal to 12400 electron volt whole divided by lambda, but this lambda should be in angstrom only. Okay. Yeah. You need to have this much of calculational part. So at the end, what you need to understand, that energy is equals to 4.1 10 to power minus 15 in frequency, that is in electron volt. It is equals to 12400 in terms of lambda into electron volt. It is equals to in this way. You need to learn about or memorize this red particular thing. Is first property very clear to you now? Is this property very clear to you now? Done, beta. So by this property, first one is complete. Now let us start now second one. Second property. Okay. Second property. Second property. Second particle is mass of proton. Second one is mass of proton. Mass of proton. So you need to know one thing, that rest mass of sorry, it is not proton, it is photon, Photon. Rest mass of photon is 0. So I will write here m naught. M naught means rest mass is always equal to 0 of photon. The rest mass of photon is 0. How, sir? So we need to write Einstein's mass energy relation. Mass energy relation. Do you know what is the relation of? E equals to mc square, or m is mass, equals to E divided by c square. This mass is my kinetic mass. So I can write here my kinetic mass came out to be E divided by c square, and E equals to h nu by c square, or I can write h, it is c by lambda, hc by lambda c square, which came out to be h divided by lambda c. So these properties you need to think about. Okay, easy or super easy? Easy or super easy? Easy or super easy? So now we are done with two properties. Now we are done with two properties. One property was energy of photon, E equals to h nu, E equals to hc by lambda. Done. Second property is mass of photon. So I will write here photon. One second, it is not proton, it is photon. Photon. Okay. Third property. Third property is momentum of photon. Momentum of photon. Next one is momentum of photon. Done. Momentum of photon is small m, and small m is equals to energy divided by your c, speed of light. Now, momentum, energy. What is energy? Sir, h nu by c. Okay. Then hc by lambda multiplied by c. Then h by C only. No, H not H by C, it is H by lambda only. H by lambda only. So just learn these things. You need to learn about these things. Okay, momentum, that means energy per C, energy H nu or Hc by lambda. You can write like this, no? So we are talking about photon, 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 and photon only. So if we are talking about photon, you need to think about it and you need to write about it. Okay. So now if you are good with this thing now, so let us do a one numerical. Let us do a numerical. And numerical is like numerical. Numerical is like here for a photon. For a photon, lambda is given as 0.2 micrometer. First part that we need to find out, energy. We need to find out energy. We need to find out energy. What is energy formula now? Sir, energy E equals to Hc by lambda. What is H? 6.63 10 to power minus 34 into C. What is C now? 3 into 10 to the power 8 whole divided by lambda means 0.2 10 to the power minus 6. It is very clear it will become 2 into 10 to the power minus 25. This is a very good formula that you need to remember. Whenever you are multiplying 6.63 10 to the power minus 34 with 3 10 to the power 8, so you will get 2 10 to the power minus 25. You need to learn about it, right? So divided by 0.2 10 to the power minus 6. Okay, 0 cancel out. Here I will multiply it with 10. So we are having 2 divided by 2 multiplied by 10 to the power minus 25 plus 1 plus 6. So we are having 1 10 to the power minus 25 plus 7. So is it 18? 10 to the power minus 18 joules. Okay, now second part now. Second one. Second B part. You have to find out momentum. Momentum. You need to find out momentum. So for momentum, which formula you will use? Sir, momentum P. Is it E divided by C? Right? So E is 10 minus 18. C. 3 10 to the power 8. Done? Or I will write here 10 multiplied by 10 to the power minus 19 minus 8 divided by 3. It came out to be 3.3 10 to the power minus 27 kilogram meter per second. Next part. C part. C part. Okay, C part. C part, we have to find out frequency. Find frequency. Find frequency. What is frequency? Sir, C equals to nu lambda. So that means frequency nu equals to C by lambda. C means 3 into 10 to the power 8. Lambda is 2 10 to the power minus 6. It is 3 divided by 2 10 to the power 14. Done. So 2 ones are 2. 1, 2 5 are 10, 1.5, 10 to the power 15 hertz. So these are my some answers and you need to learn this one. How will you get this one, and this one? Easy or super easy? Easy or super easy? Easy now. If this one is easy now, So let us do one more numerical. And numerical is like, so find linear momentum. Find linear momentum of a photon of 25 mega electron volt energy. How we can do this one now? Look. We have to find out linear momentum. So P formula is E by C. E is 25 mega, 25 10 to the power 6 whole divided by 8. 8 10 to the power, 3, no? 3 10 to the power 8. It will be 3 10 to the power 8. So is it 25 by 3? 10 to the power 6 minus 8. Done? So 3 1 is 3. 3 7s are 21. 3 8 is 24. So, but I will get here energy in joules. No. Here I need to multiply it now. Wait. So here I need to multiply it. Do you know why? Look here. E equals to 25 10 to the power 6 electron volt, but this formula is in joules. So I will write 2.25 10 to the power 6, 1.6 10 to the power minus 19 joules. Now this one is correct. Into 1.6 is 10 to the power minus 19. So it is 25 multiplied by 1.6 divided by 3, 10 to the power 6 minus 19 minus 8. So it will be 3, 24, 8 1 is 8, 9, 10. It will be 1.33 something 34, 10 to the power 19. So 27 into 6, 27 plus 6, 21. But here I put 21, it is 22. So it is minus 22 kilogram meter per second. This one is my answer. Done? Easy or super easy? Easy or super easy? Okay, next numerical. Next one is like which color of photon has greater energy? Either red or violet. So we are having Vibgyor, Vibgyor. We know that if we are going from V to R, we are going to V to R, what increases? Sir, my wavelength lambda increases. So we know that E equals to Hc by lambda. So that means E is inversely proportional to lambda. So that means energy decreases. So therefore, I can write here energy of violet is more than energy of red. This was asked in your NEET examination. This was asked in the NEET examination. One more numerical, and within 5 to 10 minutes, I will just end the whole class. Okay. So we are having some thing, right? Look, you have to give me whether it is true or false. False. First one, we are having two photons. We are having two photons. Momentum is equal. Alright, momentum. Momentum is same. Momentum is same. So if momentum is same, what about wavelength? What is P? P. Is it E by C? What is E? Is it H nu by C? Yes. Is it H by Hc by lambda into C? Is it H by lambda? So momentum is equals to H by lambda. Momentum is same. H is constant. That means lambda should be same. Lambda means same. Lambda needs to be same. If lambda needs to be same, so you were right. This particular statement is true. This one is true. So what about the second statement? What about the second statement? Second statement. Same. We are having two photons. We are having two photons. Done. Now wavelength is same. Now wavelength is same. What about their momentum? Momentum. Look now. So you can write that P equals to H by lambda now. This one is constant. This one is same. That means it should be same. No. Do you know why? Because it is a vector quantity. Vector quantity. So you will write P. Look now. If mod of P, P1 equals to mod of P2. So you will write magnitude is same. But if P1 is in I direction and P2 is in J direction with equal mod. So you cannot say it is same, no? So this statement is false. You will get this numerical in each and every book. Now, if you find the notes in a Telegram group, you will find the language of the numerical also. Okay. Last part, then we will do a tita by to the class. Last thing. Last thing is number 4. Number 4 is number of photons. Number of photons emitted per second by light source. By light source. If we are having a light source like this with power P, P capital P means power, small p means momentum. So do you know what is power? What is power? Sir, power is energy per unit time. Energy per unit time. This is power. What is energy H nu? By time t. If we are having n particles, so n means number of photons. Number of photons only. And n by t means number of photons per time. Done? So can I write now power is equals to n times h nu by t. So we have to find out n by t, which is equal to small n, which came out to be p by h nu. H nu. Or look, p is p, h is h. What is nu? C equals to nu lambda. So nu came out to be c by lambda. So I can write here c into lambda. So these are some equations that you need to remember by anyhow, so that we can perform some numericals in next class. Easy or super easy? Are these equations or everything easy or super easy? I want answer from your end. Easy, super easy. So up to this particular point, we discussed modern physics, first part, photoelectric effect and photon theory. Photoelectric effect means if light strikes the wavelength, the energy of light should be suitable. Okay, if that strikes to any metal surfaces, electron gets ejected. It is photoelectric effect. Those electrons known as photoelectrons, and the minimum energy required by your metal surfaces to get the electron out. That is a work function. Then we discuss about the photon theory, energy of photon, right? Mass of photon. Done. Momentum of photon and the number of photons. So now we are done with today's class. Okay. So thank you, Veda. Thank you for today. Next thing we will discuss in tomorrow's class. Okay. So I go up to this particular point. You find how modern physics is easy is, but only thing is the equational thing. You need to remember the equations only. Okay. I hope you are doing good. So thank you. Bye. Good night. Shabak khair. Bye, beta. Bye. Good night.